In example 2, we're going to estimate the limit as x approaches 0 from the right of 2 to the x minus 1 divided by x to the nearest 0.001. So we have a formula for a function, and we also have a graph of the function over here on the right. And so from our graph, it looks like as x approaches 0 from the right, the function values are approaching something that we could estimate as roughly 0.7 maybe. So from the graph, it looks like the answer is 0.7, but that doesn't have very high accuracy, and it's certainly not within 0.001. So to estimate this limit to the desired accuracy of 0.001, we're going to use a formula. And the way we're going to use a formula is we're going to make a table of values for different x values. So we're going to start with a small value of x, 0.1, and see what the value of 2 to the x minus 1 over x is going to be. 2 to the x minus 1 over x. We want to know what is happening as we are approaching 0 with values that are slightly bigger than 0. That's our goal. We can't plug in 0. If we tried to just plug in 0, we would get 2 to the 0 minus 1 over 0, and that is undefined. So the best we can really do is plugging in small values of x and see what happens. So let's do this. So we want to take 2 raised to the 0.1, and then we're going to subtract 1, and then we're going to divide by 0.1. And this is a job for a calculator, and when you plug this into your calculator, you will see that this is 0.718, and I can stop at that number at the third digit after the decimal because that's the accuracy that they are asking us for. Now, so the value is 0.718 that I'm getting when I'm plugging in x equals 0.1. I have no idea if this is accurate enough yet because I don't have anything to compare it with. So I need to try out some more values. Let's look at another value that's smaller, so 0.01. If I evaluate 2 to the x minus 1 over x at 0.01, I'm again plugging this into my calculator, and the value that I'm getting here is 0.696. That's pretty close to 0.718, but not within the accuracy that the problem is asking for. So I need to keep going. Now let's try another value, 0.001, and again we are computing 2 to the 0.001 minus 1 divided by 0.001, and that is 0.693. 0.693. Can we stop now? Is this good enough? Well, almost. The first 2 digits are the same for the last 2 estimates that we had, but unfortunately the third digit right here, that is different. So we are not within the desired accuracy yet, but maybe just one more, let's hope. We're going to catch it with one more value. So let's try 0.0001. And, well, if I do that, we get 2 to the 0.0001 minus 1 divided by 0.0001. Plugging that into your calculator, getting 0.693. Oh yay, 0.693. I have exactly the same digits that I got with my previous estimate, and so now I'm within the desired accuracy. So we can write down our conclusion. It looks like the limit as x approaches 0 from the right of 2 to the x minus 1 divided by x is approximately equal to 0.693 to within 0.001 of its true value. So this is great. This is a very good estimate now for this limit.